Hello everyone. You probably know that Newton established several universal laws. In this video, we're talking about his most famous three laws of motion. His first law, Newton's first law, states that an object at rest remains at rest as long as no force acts on it, and an object in motion stays in motion as long as no net force acts on it. Let's take an example. Suppose you have a flat and really smooth surface. Take ice for instance, and you toss a ball on the surface. The ball will probably continue moving for a long period of time. And if another force doesn't act on it, then it will probably just move on forever. Another common example, one in which you've probably even experienced, is when you're sitting on a speeding car, and that car suddenly comes to a stop. You feel like some force pushed you forward, right? Now when the car was moving, you were moving with the same velocity as the car because you are part of the car, as you're sitting in it. But when that car suddenly comes to a stop, your body is still acclimated to the velocity of the car itself. Your body comes forward unconsciously. But you, because you're conscious of yourself, you stop yourself from going forward. Newton's second law states that an object's acceleration depends on two things. 1. The object's mass. 2. The net force acting on an object. The famous equation that accompanies this law is F equals ma. Now suppose we have a rough surface, one on which an object is hard to continue moving on. For example, let's take a rug. Now on that rug you roll a ball. That ball wouldn't last long walking or moving on that surface because there's friction. It's a force that prevents an object from moving on a rough surface. When you solve a problem with friction, the acceleration most probably will have a minus sign. That's because velocity slows down. But what if the acceleration of an object is zero? On first thought, you may think that the object may be at rest. Well, that is one case. Another case in which the velocity of an object or the speed of an object is constant, which means there's no force acting on an object because the acceleration is zero. Newton's third law. It states that for every action force, there is an equal but opposite in direction reaction force. An action force is any force applied to an object. Every force has a reaction force, but the reaction and action forces act on different objects. For example, let's take a small box in which you push on a smooth surface. Now to keep that box moving, you will only give it a force in the beginning, right? As I stated before, no need for a force to keep that object moving at a constant speed. But regardless of the speed and acceleration, now we're looking at the force itself. When you give the box a force from your hand, according to Newton's third law, the box exerts a force on your hand. Another easy to understand example is swimming. When you swim, and you move your hands forward, pushing the water inside, you exert a force from your hand on the water. But how do you move forward when you are pushing the water? Well, it's because the water pushes your hand back, pushes your body forward, as a result of the force you exert on it. After learning these laws, people may develop many misconceptions about them. And now, in here, I'm going to talk about the three most common misconceptions about these laws. The first is that people claim that because of Newton's third law, objects shouldn't move in a way that the forces cancel. But we know that this isn't true. So when do forces actually cancel? Take this as an example. You have a box on a smooth surface. On the left hand of the box, a force is applied to move it forward. But then, on the other side of the box, a force is applied on the opposite direction. In this case, the net force is zero, because these two forces that are applied on the box are of equal value, but opposite direction. They will have a sum of 0. This isn't Newton's third law, because Newton's third law states that when you apply a force on an object, the object in which you applied the force on will apply the force on you. That means the forces are applied on different objects. The action force is on an object, and the reaction force is on the object that applied that source. Another common misconception is that for an object to move with constant speed, or not changing speed, a constant force must be applied. Well, to prove that this isn't true, suppose a friend of yours, or you, for example, tossed a ball on a smooth surface. After you toss the ball and the ball is already moving on the ground, a person or a friend of yours enters the room. The person who enters the room will see the ball moving alone without any force exerted on it. How does that happen? Well, this proves that for an object to move with a constant speed, there is no need for a constant force to be applied on it. But rather, when an object has a force applied to it, it either accelerates or decelerates, meaning its speed changes. The third misconception is that some objects fall faster than others. Well, this is definitely wrong, because gravity is constant. It's the same everywhere on Earth, on every object. Take this famous riddle as an example, where a ball and a feather are dropped from a specific height. The riddle requires you to determine which of these two objects reach the ground first. The correct answer is that they all reach the ground on the same time. But when you do this experiment in reality, you may find that the ball is the one object that reaches first. Why is that? It's because there's a force acting on the leaf that stops it from going downwards as quickly as the ball does. It's called air resistance, in which air but holds the leaf back from falling, as does the ball. I hope this video benefits you, and thank you for watching.